Hi there, my name is Saeid. I'm with Prep 101. In this primary, we will talk about trigonometric identities. Even though you will not be tested in trigonometric identities in Math 1 ZA3 at McMaster, you need to be familiar with these identities in order to answer many questions on limits, derivatives, and later on in integrals in this course. Okay, let's get started.
Here are some useful trigonometric identities. So this first one is the result of Pythagorean theorem on the unit circle. Sine squared plus cosine squared equals 1. We can rearrange it and solve it for sine squared. That would be 1 minus cos squared, or we can solve it for cosine squared. That would be 1 minus sine squared. So these are essentially the same identities. Now, if I divide both sides of this equation by cosine squared, then that gives me this one. So that's also a nice identity that relates tan squared to secant squared and vice versa. And if I divide both sides of this identity by sine squared, then that gives me this identity. That's also very useful. This one connects cotan squared to cosecant squared and vice versa. Now, this one is the double angle identity for sine, which is 2 sine x cosine x. And these three are double angle identities for cosine. So for cosine, for double angle cosine, we actually have 3 different identities. And you can easily prove one from the others. For example, from this one, we can actually substitute this cosine squared from here, 1 minus sine squared x, and that gives us this identity. So as I said, you can easily convert them. Depending on the problem that you're solving, you might want to use one of these only. Obviously, if you need only sine in your answer, you're going to go with this one. If you need cosine, you can go with this one. And if you need both of them, then you will go with the last one. We also have these identities for addition and subtraction of angles. So sum of x plus y, sine of x plus y, sine of x minus y, and the same thing with cosine. We also need to know the definition of tan, which is sine over cosine, cotan, which is cosine over sine, secant, which is 1 over cosine, and cosecant, which is 1 over sine x. Okay. Let's do some examples. In this first identity, we actually have to prove it. And usually when we are proving identities, we'll start from one side that has more terms and more complicated, and we'll try to use identities and simplify them to get to the other side that is more simplified. So in this case, we're going to start with the left-hand side. And you see how you have 2 fractions on the right side. There's no fraction, so we probably need to take the common denominator. The common denominator, what I'm going to do is to multiply those. So multiply both denominators in order to get a common denominator. And obviously, I'm going to multiply this one by 1 plus sine theta. That will be the first fraction. And multiply this by 1 minus sine theta. So I just took the common denominator on these 2 fractions. Here you see that you're going to cancel out these 2. So you end up getting a 2 here. The denominator, you remember this identity that if you have a minus b times a plus b, the answer would be difference of these squares. So right now I have a minus b right here and then a plus b right here. So if I multiply those, then that gives me a squared, which is 1 squared, minus b squared, which is sine squared of theta. Now, you remember this 1 minus sine squared from the previous page that I showed you. 1 minus sine squared is actually cosine squared. So I write 2 over cosine squared of theta. And technically, I have 1 over cosine squared, which is secant, so that would be 2 secant squared of theta. And this would be your right-hand side. So we started from left-hand side, we used identities, we simplified, and we got to the right-hand side. So we proved this identity. Now let's do a different example. You're given cotan of some angle equals 3. And you know that beta, that angle, is between pi to 2 pi. We don't know exactly where that is, but we're given a range for that. So there are different ways you can solve this type of problem. One is to use identities. We know right now that our beta is from here to here. We don't know whether we're in the third quadrant or in the fourth quadrant. We could be in either of those. So the technique that we usually use here, and we have to find other trigonometric ratios, like we need to find sine of beta, cosine beta. We're not going to use our calculator here to find beta. And remember, in many first year courses in engineering and science, you're not allowed to use a calculator. The idea here is I want to relate cotan to sine cosine. So one useful trick here is to use the triangle. And if you haven't watched the primer that we made on trigonometry and CAS rule, the basic trigonometry, I encourage you to watch that. So I have some angle beta. I don't know what that angle is, but I know that cotan of that angle is equal to 3. So cotan of beta is equal to 3. Cotan is adjacent over hypotenuse. So I need two numbers whose ratio cotan beta is equal to 3, which I can write it as 3 over 1. So I need two numbers that when I divide them, I get 3 over 1. So the best numbers or the easiest set would be 3 and 1. So 3 and 1. So right now, you see that tan of beta is 1 over 3 and cotan of beta is just 3. Now, if I have these, I can use the Pythagorean theorem to actually find the hypotenuse, which is going to be 3 squared, which is 9 plus 1 squared. So that will be square root of 10. Now that I have these three sides, I should be able to find all trigonometric ratios. The thing is, I still don't know whether beta is in the third quadrant or fourth quadrant. Because these sine, cosine, tan, and cotan depend on the quadrant that this is located in. So from here, I know that it could be either in the third quadrant or fourth quadrant, but that's not enough. I need to know exactly where my beta is. When I also look at cotan, I see that I got a positive value for cotan. And if you remember the CAS rule, only in the third quadrant, between these two, only in the third quadrant cotan is positive, because in the fourth quadrant cotan is negative. So that means we're not here, we're actually in the third quadrant. And even though beta in the question, we are given a range, which is a wider range between pi to 2 pi, but beta is actually in the third quadrant. So this one, I'm going to write beta is between pi and 3 pi over 2. And this means I can find sine of beta now, cosine of beta, tan of beta, cotan obviously is given, so secant of beta, and cosecant beta. So as you see here, I can use these identities to actually find, or I can use the sides to find all of these ratios. So sine is adjacent, 1 over root 10, opposite over hypotenuse. At the same time, I know I'm the third quadrant, so sine must be negative. Cosine is adjacent over hypotenuse. And I also know that cosine is negative in the third quadrant. Tan is opposite over adjacent, and tan is positive in the third quadrant. Secant is 1 over cosine, so all I need to do is to just find the reciprocal of this fraction. So that would be negative root 10 over 3. And cosecant is 1 over sine. So I just need to find reciprocal of this one. So that would be negative root 10. So this is how we solve this type of question. Obviously, you can use those previous identities and write this one as sine over cosine, but this is much easier way. If you're given one trigonometric ratio and you need to find the other trigonometric ratio. Once again, I use the combination of these two pieces. The fact that beta is between pi to 2 pi and the fact that cotan is positive. That's how I was able to locate beta in the third quadrant.
I hope that you found this useful. If so, check out more foundations of first year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems and how to do that with confidence and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.